Hey guys, Andy here at MVP Java. Today I'm going to show you how to deploy a Spring Boot war application to a Tomcat server running in a Docker container, much like I did in the last tutorial here on my YouTube channel. This was the last one that I came up with, Spring Boot, Tomcat on Docker. I'm going to extend that example, so I'm not going to cover the whole thing all over again. So if you have missed that video, you really need to check that out before you come over and follow this one. What's going to be different in this one is we're going to link the Tomcat container to a MongoDB instance running in another Docker container, and we're going to link both containers up together. I'm also going to throw a third container there that's going to be Firefox that'll automatically open up to the URL to the application so that we can get started. So all of this is going to get orchestrated by using DockerCompose, okay, that I'm going to cover in this tutorial, which I skimmed over on the last tutorial on purpose. Okay, now the tutorial also is going to be loosely based on this tutorial here, where I integrate Spring Data and MongoDB. So all the details of exactly how to go and do that is in this tutorial. I've decided to kind of port it over to a web application because this one uses JavaFX, and by doing so concentrate on just the Docker deployment. Okay, so but I will go over a little bit of what's going on in the Spring Boot application, obviously. So we're going to have 3 containers running. So the name of the game is going to be how to reproduce this environment in a consistent way via using DockerCompose to bring up all your Docker containers in any environment. Okay, but before we do that, you'll see that I'm going to be using my GitHub account with all the source code here, and you'll be able to simply clone this repository, and I'm going to do this with you, okay? And then just simply execute the DockerCompose file and just recreate the entire environment. By the time really it takes just to download the images, okay? So in this demo, obviously it's going to be very quickly since the images are also local on my machine. And my DockerHub account also has the latest image of the tutorial up there. So just like I showed you how to push a Docker image last tutorial, that was this Docker Tomcat image over here, we now have the Docker Tomcat with MongoDB as well. Okay, so I'm not going to show you how to push it again in this tutorial since I covered last one, but it is up there if you're wondering how I got that afterwards in the demo. Okay, so let's say we're going to look at our application very, very soon, but eventually what you guys are going to do, I'm just going to go to the end result here, is you're just going to do a DockerCompose. Right, I'm in the directory here where the source code is. You see a DockerCompose file there. I'm just going to say DockerCompose up, and I'm going to run this in the background, -D. I'm going to run this as a daemon job. And you're going to see the 3 containers actually coming up, right? I'll cover this just in a second. You see the Mongo comes up first, the Tomcat, and the Firefox. It knows which one to start as a dependency, since Mongo has to be up before Tomcat, and Tomcat has to be up before Firefox. Now, you'll see here that Firefox is also running in a container, and I've opened up 2 pages here. If I just refresh this, it will connect to the Tomcat server, and you see here I used an alias for the IP address. I'll show you how I did that so you wouldn't have to log into the container and figure out your IP address and then put it up here. That's very time consuming every single time you want to run it. You can see here that we got the same message as we did in the last tutorial, right? So you know the Tomcat war file was deployed, and you also see here that we're connected to MongoDB, to the database called demo, and containing a collection called logs, right? Now the whole point of this demo is that every time you come to the home page, it increases a hit counter, and you can go over here to the hits URL, and you'll see how many times you actually hit that home page. Now this data has been saved in MongoDB, so we know that Tomcat has been properly linked to MongoDB, and the hit counter is being properly logged into MongoDB and then read. So if I actually go back here and refresh this and go back to the hits page, I should go see this go to 3. And that's exactly what happens. Okay, so we know all the links are good. It's an operational application. So now in order to bring it down, really all you have to do is DockerCompose, and then I would say down. Okay, So Before I do that though, before I bring the whole thing down, I'm going to go show you a little bit of code and how this was actually possible, and we'll come back on the command line to see some more great Docker Compose commands and how we can go inside the containers, look at the logs, and play with the kind of life cycle of this service. Okay, so let's do that right now. So first thing we're going to look at is the Docker Compose file. Now, in the last tutorial, I showed you how to start your containers on the command line. And that's all good. You need to know that. But when you have multiple containers running, right, in this case we're going to have 3, you don't want to go on the command line and type all these commands and know in which order you have to execute those commands, and then know in what order you have to shut them down. We would like something to orchestrate the whole thing for us automatically, and that's what Docker Compose brings to the table. It orchestrates all of this for us as long as we tell it how to. And how we're going to tell it how to is by filling out, I guess you want to call it, the manifest, the plan. This is the DockerCompose.yaml file, right? So over here, you're coming up with 3 service names over here. And I'm purposely using the Docker Compose version 1. This presently at version 3. There's still a lot of code out there, a lot of configuration files out there that are using version 1. So I want to showcase that here. And in the next tutorial, I'll jump to version 2 or 3. And again, this is done on purpose just to make sure we're going to cover all the bases. Just like in the last tutorial, I covered the Spotify Maven plugin. There's others out there. I'm going to continue with Spotify for this tutorial, and then the next tutorial we'll head over to the cloud. So over here we've got a service called Tomcat Server. You can call it anything you want, and we can reference this name later on in the other container sections. I'm referring to an image that I already pushed onto my DockerHub account. This is the DockerHub account that I had showed you just before over here, right? This image over here. Oh, I didn't know you could move that. That's cool. So I'm making reference to that image. Now, obviously, it's local on my Docker host as well, since I already downloaded it. I'm giving it a container name. This is like what you would do on the command line with the minus name argument. I'm exposing port 80. Now, this is important here because usually you'll see something like 80:80. And over here, I'm actually just putting 8080, which means that it's mapping to the ephemeral port on the Docker host, which is 0.0.0.0. So it'll pick a random port number, actually within a range, and assign it to this. And this is important because if you're going to run multiple instances of a Tomcat server or a MongoDB or whatever, you're going to want this to be seamless for you. If you put something like 8080 and then you try to run like 5 instances of a certain service, then you're going to get port conflict. So this is a way around that. This is the host name. So the host name is going to be the output of the hostname command. If you go inside the container, or even you go take a look at the etc host file, it should also be in there. And this is where a lot of the magic is happening to allow the containers to communicate with each other. The links, right? When you say links, you can think of this as a key value pair here separated with a colon, which means that the key is the name of another service, right? So this links down here, and this is an alias. Now the alias is very important because it's going to be populated inside the container of Tomcat in this instance here, and it's going to hold the IP address of the MongoDB instance. So in the etc host file, we're going to see an entry with Mongo and its IP address. So we don't have to hard code anything. And even if we did hard code something, right, how would you know in advance what to hard code to? So this is just an alias. It's going to be extremely useful for us to communicate with another Docker container. MongoDB follows the same logic. Here's an official image that I found on DockerHub for Mongo. Here's the name. I'm also mapping the default port to the ephemeral port on the Docker host, giving it a very logical host name, and the volumes here that are needed to map the database inside the MongoDB container to a directory inside my Docker host. Okay. Now, one last one is the browser, right? So the browser, we're using Firefox. I found a really nice image on DockerHub, and I'm following the same logic as before. This time I'm linking to the Tomcat server, which is this guy up here, right? And also, there's going to be an alias called Tomcat inside the etc hosts file of the browser container, which I'm calling Firefox. So you'll see that when I do a docker ps command. in the output, and you will see the IP address in there. And that's actually the alias I'm also used in the URL bar, right? So in the URL bar here, you'll see Tomcat. So Tomcat is actually the alias that's being used as the IP address, which is obviously super convenient for us. Okay, again, the host name, the environment. Now this I covered in my first tutorial, actually having to do with setting up your developer environment, this guy over here, with Docker, and how we have to go about specifying the display and exposing the X11 socket on the Docker host in order to have a visual application display when you're firing off your container. Okay, so that's the same thing as that first tutorial. I'm also mapping the home directory of my Docker host to the home directory inside the container. If you don't do this step, it's actually not going to start. Okay, and the command, notice here that I put it all on one line. Usually you'll see in a YAML file kind of this format where you do an enter and then you have a little dash. If you don't do it this way, because there's multiple arguments here, you can see 3 arguments, it's not going to work. It was actually a source of frustration. I couldn't understand why my arguments weren't being taken until I said, let me try this on one line, and it worked. So it's going to open up a new instance of a browser. So if you already have a browser running, it's not going to open a new tab, right? And it actually wouldn't work if you had a new tab open up, because that alias is not populated inside that instance. That alias I'm talking about, Tomcat, it wouldn't have been populated inside that already running instance of Firefox. So this opens up a brand new instance and opens up 2 new URLs and 2 separate tabs like I showed you. Okay, so this file over here is directly responsible for orchestrating the entire process, and the practice is to put it at the root of your project as a convenience. So someone that goes, for example, to your DockerHub, or not your DockerHub, but your GitHub account, sees it right off the root and knows that it clones it and it could just run this entire environment, right? So it's very, very practical. So that is the DockerCompose file that we just ran. The other stuff that we're going to need to know for the project has to do with the code, right? So again, this code here was inspired by that project that I already had done on my channel here in terms of the logging with the Spring data and the MongoDB. I would say this is probably the most underrated video I've ever done. It's only got about 628 views, but I'm telling you, I think that's my favorite tutorial as well. It's an excellent tutorial. Have a good look at it. I'm sure you're going to be very impressed with that tutorial. I think my search engine optimizations are not up to par, and that's why it's not getting a lot of views. You be the judge. So let's go back to the actual code. All right, so the actual code is very simplistic because we don't want to dwell too much on Spring Boot, but it follows the same logic as the last tutorial, where we have some URLs mapped, the hits and the root context, and we obviously get back the same message here: Spring Boot war deployment and Tomcat container successful, and that exactly coincides with what we saw over here, right? And the Mongo service that I'm using, I'm auto-wiring a Mongo service, and that Mongo service is actually in the background using Spring data. It's injecting a Mongo template that I cover very well in that other tutorial, and it's able to interact with Mongo. All right, so we're just basically logging to Mongo and then reading the information from Mongo. Okay, so that's just normal Spring Boot stuff. Obviously, if you just want to even dwell inside this code, you can go on the GitHub account and just snoop around. Very simplistic. Like I said, if you want to have a full thorough example on this, go check out other tutorial. Now, the nice thing about the log record that I'm writing out is it's going to have the date. All right, so we'll be able to actually go into MongoDB and just make sure that the latest timestamp has been written out, even though we can simply see on the page, the hits page, that the counter is incrementing. It's always nice to trust but verify. Okay, so what I really want to dwell on though in this example is the Mongo configuration. Right, the Mongo configuration here is going to get picked up, and next time I want a Mongo template that's auto-wired, it's going to go and build my MongoDB factory. And what's very important is that I do not hard code the host name and I do not hard code the port number, right? So you see here my host name, I have Mongo. And the reason why I have Mongo is because in the container that's running Tomcat, which is obviously hosting the Spring Boot application, it's going to look at its etc hosts file. And because I container linked it here with Mongo as the alias, it'll find the IP address. So that's really sweet, okay? The other thing is I'm using a property or system property for MongoDB port, or just Mongo port rather. So here I'm going to show you this inside the container, how I knew to go get this specific variable. But before I do, let me just say that when you link containers, you're going to see that the container is going to contain, right, kind of weird to say, but lots of environmental variables dealing with port numbers, IPs, and whatnot. And we'll be able to take advantage of that, and if you want, use them directly or parse them to go get a piece of information. So in my case, I actually, in this code here, I actually went and called a private method to parse that environmental variable off the colon and go get the second token, which if you see here, actually the second token is the port number. And you'll see why I did that in a second, okay? Because by just getting the port number, it's not enough. You're going to see that there's actually still some hard coding going on in the background, which is a little bit annoying when you don't know the reason why, but I'm definitely going to explain the reason why. So now that we see the application, right, the only last thing to do is look at the pom.xml file and the Docker file. Now the Docker file has not changed whatsoever from the Docker file in the last tutorial, right? So this guy over here, same thing, nothing's different. Takes the war file, puts it in the Tomcat web apps directory, and then we basically call it java-jar and have the whole thing deployed for us, okay? So there's no need to go over all of that again. Over here, I'm still using the Spotify Docker Maven plugin, and I still am using this IP address for my Docker host, which is usually the default. So if ever you weren't able to run this, bear this in mind that maybe your IP address is different for your Docker host. If it is, I'm actually interested in knowing how many people would come across this problem, because usually this is in the realm of learning, of tutorials and everything like this. I would be surprised if it was different. Obviously, in more of a production environment, I wouldn't be. But I wouldn't expect you to take this code for production anyways. So everything else is the same, okay? And I showed you in this case, if you wanted to push the image to DockerHub, that there was a little flag that I had inside my Maven commands, which I kept over here for us to just look at quickly. This is the one I usually run. Maven clean package, then the Spotify Docker build goal, and I use the Spotify flag here, skip Docker push, because every time I make a code change, I don't want to push this to DockerHub. That takes way too long, okay? So once I know I've tested, everything's cool, then I will push the image to DockerHub, and I've already done that before showing you this tutorial, and I showed you also how I did that in the last tutorial, so there's no reason to do it a second time. Very time consuming for a tutorial. So now that we have everything in play, we can go back on the command line, and we can actually see, if we say DockerCompose PS, this is the same thing as doing Docker PS, except it'll show you the containers running underneath the realm or the service that you define. So we defined 3 with the name Firefox, Mongo, and Tomcat. And you can see here the port numbers that I said we were mapping to the ephemeral port. Remember, 0.0.0.0. A random port gets assigned to them. So there's no hard coding involved, so we can scale this up very nicely. Now, DockerCompose offers us the ability to scale up or scale down a project or a service, saying I want 5 of these, right? I'm not going to do that in this tutorial because it doesn't really make sense, because I didn't, configure any load balancing or anything like that. But I will get into that in another tutorial. Okay, so now that we have, we can see everything there, we can just also do a Docker images here, just to take a look at what's on the system. And you can see here about an hour ago, I did the final compilation of the project. And I have here 2 tags, one latest, one 2.0, that has the Tomcat MongoDB image. All right, so I think we're ready now to actually get a little bit more into DockerCompose. So we know that the containers are running. We just did a DockerCompose PS. What if you wanted to go and actually go look inside the MongoDB container? So we can say Docker, I want to execute a command. Okay, actually let me just go back up to the home directory just to give us some more room here on the prompt, because that is a pretty long prompt. Docker exec, and I want to execute, let's say, an interactive sudo terminal. I know the name of the container is Mongo, and I want to execute the Mongo shell, right? So there we go. Got the Mongo shell running. I'm going to do CLS, and now I can actually take a look at the databases, right? And I could see here that I'm in the code. I'm using the demo, right? Just in case I did not show you that. There you go. I'm using the demo DB. Okay, so I'm using demo, so I'm going to say use demo, and I want to show the collections in here. I think it's called logs. There it is. There's only one in there, and I'm going to do a find. I want to see everything in there. So in the database, I'm going to specify the logs collection, and I want to find all the records in there, and I want to print it in a kind of a pretty, they call it a pretty fashion. It's much nicer to look at than it is in the other way. So you can see here that I have 3 entries. So that coincides with, I think the counter was 3 here, right? So if I go here and I update this, come back here, refresh this, and I go back to over here, I should have a timestamp. If I do date, that is quite close to 21:33. There you go, 22:21:43. Okay, so a little bit of a time drift, but you can see that it's getting updated, and we do have 4 in there. So we know we have the container properly connected to Tomcat, and if we actually go take a look at what's going on inside the container now, actually what I'm going to do is I'm going to exit here, and I'm going to go back into Mongo, and I'm going to execute, I'm going to go into the Tomcat container rather, and you can see here if I do a tab that you can see all the containers running. Even NetBeans is running in a container, right? I want to go into the Tomcat container this time, okay? And in the Tomcat container, I'm going to execute rather a shell, and in there, I want to show you the environmental variables, right? You can see there's a whole bunch of Mongo variables here. So actually, if I clear this and I do the same thing and I grep this for anything that looks like Mongo, you're going to get all these environmental variables. These all get injected because we linked the containers together, okay? And you'll notice that if I wanted the port number, right, that here it's just sitting there for me to go take, but look at the name of the environmental variable, right? It's horrible because you have the number of the port number inside the variable, so you've hard-coded it as well in there, so that's really not going to help. So the way around this, okay, is every time a new Mongo instance is required, they're going to come up with all this set of Mongo environmental variables for each instance. So if you had another instance with port number 27018, you'd have this variable called Mongo port 27018, and so on and so forth. So you have to decide which one you're going to take, and the answer to that is Mongo port. Even if you had 5 instances of MongoDB running, there would only be one of these, okay? Think of it as your endpoint that then would get load balanced to all the other ones, right? And what you got to do is you got to parse this string that I showed you in the code, and you got to go get this last token, okay? And that's what I want to do. So that's all environmental variables that you can make use of. And the other thing is if we vi the etc host file, I must have not put the S. That is a common mistake. All right. You'll notice that over here, I have the alias Tomcat. That was because I called it the host name for this container. But I also have Mongo, right? So if you remember in the code, when we looked at the DockerCompose file, I had done the link, right? In the link, I said, I want to create an alias called Mongo. And that's exactly what this alias is here. So now I have access to the IP address in my code without having to worry about hard coding the IP address. And I just showed you how to not worry about the port number as well. So that's pretty cool. Now, we could also take a look, for example, at the Firefox, right? Is that what I call it? I call it browser. I call it Firefox, this one, okay? And again, execute a shell in there, and I could VI the etc host file, and you'll see the alias for Tomcat there. And Firefox is there because that was the name that I gave down here, my host name, right? Firefox for the host name. Whoops, excuse me, for the host name. So it all makes sense, okay, once you know where the information is and how you can make very good use of it. So now I can exit this guy, and let's say you want to take a look at the logs, right? So I can say again, DockerCompose, and if I just say logs, what's going to happen is it's going to show me the logs for every single container running in there. Now, I must have typed something wrong here. Yeah, and that's obvious. I just tried it again. It's because I'm not in the directory where the DockerCompose YAML file is, right? So that makes total sense. So I have Docker PS now. Okay, that makes more sense. So if I do logs, what's going to happen is it's going to spit out the logs. That won't quite quickly, actually. You have Mongo up here, you have Tomcat up here, and you're probably going to have Firefox up here, right? So you see all the kind of the tailing of all the logs from everything. But obviously that is a little bit disturbing to see all that output going out. So what you can do is you can say DockerCompose logs, and if you do tab, you'll see that you have the names here that you gave your services, right? These are the names of the services right here, MongoDB, browser, and Tomcat Server inside your YAML file. So let's say I just want to say, I don't know, show me the Tomcat Server 1, and then you see just that, okay? That doesn't stop you also from going inside the container like I showed you with the exec command, and then going and actually looking and VIing or tailing -f the files or something like that. There's also a way to tail a file through DockerCompose. I actually think it's through the -f option. So if you actually would do DockerCompose logs -f Tomcat Server, you could actually be able to tail the log, okay? So let me just get out of here. And if you want to bring the whole thing down, right, it's DockerCompose down. This will actually put them down, stop them in the right order. And if you, a good idea is to do -v for volumes to make sure you don't, you know, have what we call orphan volumes, so data that's just lying around that can't be associated with a container because it's gone. So in this case here, you can see that Firefox is being shut down first, Tomcat, then Mongo, and then it's removing the containers automatically because there is no --rm in DockerCompose on the command line. So now, you used to have to do it manually before, but now in this version of Docker, you'll notice that the whole thing just is properly shut down. The only thing you really got to watch out for, though, is the -v for the -volume. So now that you guys know how to bring this whole environment up, let's take a look at the DockerHub, okay, project, and see how we can clone this whole thing and have it running on your computer very easily. Okay, so let's go to the command line, but let me just copy this URL here. Okay, let's go, let's say to, let's make this easy on the eyes. Let's go to the temp directory. We'll make a directory demo, and we're gonna git clone this. Oh, didn't grab it. No, let me go back. Oh my. All right, copy this, go back, and that's not working anymore. What if I do? No. Let's try this again. All right, so I finally got that thing copied. I have no idea why it wasn't copying there, but here's obviously the clone. There's the URL to the GitHub account. So press enter, the whole thing gets downloaded within seconds, just because there's not much in there. We do an ls, right? We've got our application there, and right off the bat, you can see the DockerCompose file is waiting for us to just DockerCompose up, right? Run that in the background so the prompt doesn't go away. And just like before, the whole thing just comes back up. Okay, so let me just bring this down here. Oh, I might have just touched the tab by accident. refresh this, come here. Obviously the database here is stateful, right? Because I did a volume mapping, and boom, you have the whole environment reproducible now without a problem. Okay, and that's exactly what's going to happen to you guys when you do exactly that. So next thing on the list is, how do I make a code change, right, and then run this thing again? Well, now, there is an issue here with this type of setup because we're progressively going towards, getting the perfect setup of working with a continuous integration server or anything like that. We're not there yet, right? We're taking a layered approach, a staged approach. This is the third tutorial, right? We're going to get there though. Right now, we run the risk of the source code being out of sync with the image that is actually on DockerHub, right? Because this guy I actually pushed manually, and that's really the key word here. I'm manually pushing this from my IDE whenever I say, hey, I think it's time to push this. I think I'm ready, right? With doing the run Maven, and I push the image. But nothing is forcing me to do that. There's no automation there that picks up my push to my GitHub account and automates the whole building of that Docker image. So you have to bear that in mind, is that the source code can drift from the image. So in this case here, if you wanted to actually compile the source code, let's say you come in here, and let's say we go to main, and we go to Java, and let's see what's in here. I want to look for the main, right? So if I go vi main.java, and I want to make a code change here, let's do something really simple, right? And come up here and just write the number 2, and I want to recompile the whole thing. This is how I would have to make sure that everything is in sync with the image, because the image right now, what's going to happen is once I build the image, Spotify is going to build that image on my local system, right? So if I say Docker PS right now, you'll see, or Docker images, excuse me, you'll see that this guy here was built about an hour ago. Okay, so now that I'm in my root of my project, right, that I have the source code for, I can actually run a Maven. Let me clean everything out, or else if you don't run clean, your number 2, your code change is not going to get picked up here. Okay, and you can run a package or an install. I'm just going to run a package since I don't need to share this with another project right now. It's not going to go inside the repository. And here is the goal from Spotify Docker build. It's going to build, obviously do the whole thing very fast because I've done this on my computer already. I actually have a unit test there. It's executing the unit test, and off it goes. Spotify is building now the image, as you can clearly see, very, very quickly. And now if I do Docker images, right, you see that it's been updated. So my local copy has been updated. And now if I do DockerCompose up, I still get the whole environment created for me. You notice this time I didn't do -d. So what happens is, my console is taken up with the logs. And you'll see here Docker War 2, right? So let me refresh this. Now I'm glad this is not coming up right away, because it brings me to a point I want to discuss, is that the containers, when they're started, because we put the dependencies in terms of the links, they get started in the right order. But for example, Firefox does not wait for Tomcat to be up and running and the application deployed. That it doesn't do. And it doesn't do that because DockerCompose takes the approach that if it did do that by default, then your application might suffer a failure in that the whole thing couldn't come up, because it would wait maybe for an instance that maybe crashed or that was sort of like in a state where it was waiting forever. So this is a graceful sort of degradation where the application still comes up even if there's a node that's not running, or not running but ready. In this case, Tomcat having deployed the Spring Boot war file. Now, we just needed to wait a couple of seconds and refresh, and off it went. But if you did need that, there's a couple of ways to go around that. There's some like wait functions or scripts, Dockerize. There's a couple of hacks out there. I didn't do it for the tutorial because I did feel it was kind of hacky, and the tutorial really didn't call for it. But I think you really need to know that if ever you needed to deploy something that really depended on another container instance being up and running and fully ready before another one came up, then you could take a look at some kind of hacky options that are out there that require some scripting. Okay, so now that we have everything up and running, now you know, right, how to bring this up, bring this down, and if you have the logger up here, or the logs up, you can do Control-C. The thing gets stopped, okay, but it doesn't do it in the best of fashions. Okay, so in this case here, usually I would do a DockerCompose down, maybe from another terminal, but in this case here, you can also do DockerCompose stop, make sure that everything, even a remove, minus the volumes, force it if it has to. See, some stuff wasn't removed properly. That you have to do when you don't use the -D option. That's why I like to use the -D option, and then just do down. The whole thing gets done for me. Really nice. So a lesson to be learned here, right, is that if you don't have a continuous integration build server, and there's many, this is a huge subject. There's so much out there right now with the cloud, okay? That you run the risk of the source code being out of sync with the image, right? So for now, we have an image on our local system that is up to date, right? Because we just recompiled the whole thing. We ran a Maven goal, 3 minutes. But if you take a look at the DockerHub image right now, if you would run this one, if you would pull this one from this repo, it would not have the 2. Right? So you see here how they're out of sync. So really what we need is a mechanism in place to automate, to have a trigger that every time the code changes, everything automatically gets recompiled, pushed onto a container, and that image pushed onto DockerHub. And that, as they say, is a question or a topic for another tutorial. All right, guys, hope you enjoyed that. And until next time, I'll get the next one ready for you. Ciao.